Step 2 is about converting the weak entities into relations. So strong entity can be converted straightforward. Coming to weak entities, there have to be some extra things here. Let us take an example. Let us say there is employee relation or entity. Okay, this is the employee entity, and there is a weak entity called dependents. Okay, and both are related through identifying relation. Okay, this is the identifying relationship, right? And now assume that the attributes of this weak entity are, one is name, which means the dependent name, and other is, let's say, is, and other is relation. Relation means what, how is the dependent related to the employee. Okay, and now within this dependence table or this entity, we don't have any primary key, which means we cannot identify any entity in the dependents uniquely. But then what we could do is, there is something called as partial key. Partial key means we cannot identify anything uniquely, but then given the employee, for a given employee we can use this particular key, particular thing as the key, and we can distinguish among various dependents. Among all the dependents over all the employees, we will not be able to identify it, but then given a particular employee or given the dependents of particular employee, we will be able to identify it. Such a key is called as partial key. Let us assume that this name, this particular thing, is a partial key, right? Partial key means for a particular employee, if I give you the name of the dependent, I'll be able to identify the dependent entity. Okay, now I want to convert this into the table. Then what I do is create a relation as it is. I'm talking about the schema. Okay, create the relation as it is and have all the attributes. One is name, other is, and the other is relation, right? And along with that, let us assume that this entity is this employee is a strong entity which is already created. Let us say there is employee number, which is primary key, and the employee name. These are the two attributes, and that particular relation is already created because it is a strong entity. So it is having employee number and employee name, right? Now after doing this, if it is a weak entity, what is that we are supposed to do is we have to add all the primary keys. Understand this? We have to add all the primary key attributes of the owner entity. This is the owner entity, right? This is owning this dependent. Okay, and moreover the participation has to be total, right? See, this is the owner entity and this is the dependent entity, right? And now this is the identifying relation. Now what is that I'm saying is, once you create the table or the relation for this weak entity, you add all the primary key attributes of the owner entity into this one, right? So what are the primary key attributes of the owner entity? Employee number. Therefore add employee number into this and you add it as a foreign key, which means this particular key, this foreign key, will be referring to the primary key there. In case if you have more than one attribute here as the primary key, then you are supposed to add all those attributes as the super key, foreign key, and you are supposed to refer to that primary key. Got it? Then what about the primary key of this table? The primary key of the other one, which means the foreign key, along with the partial key, which means this one. These two are going to make up the primary key, where name must be a partial key. So what is a partial key is, see, what I mean by partial key is, if you have a table like this, right? Now given that partial key, you will not be able to identify a tuple uniquely in this table, but then given the partial key and then the employee number, which means for a particular employee the dependents will be only few, and in this few, given that partial key, you will be able to identify that particular tuple. That is about the partial key. Partial key means you will not be able to identify a particular tuple uniquely in the entire table, but then given a part of the table, how can I know the part of the table? Only the dependence on one employee, right? Given the part of the table, inside this part of the table, you can use that partial key to identify a tuple uniquely, right? So things that you have to keep in mind here is, one is you can directly make a table for this, the relation, and simple attributes directly go into it. In case of any composite attributes, break them and put them there. And in case of this multi-valued attributes, we shall see it later, right? And you take the actual whatever it is there, actual primary key of the owning entity, you add it as the foreign key, and you see that that particular thing refers here, right? And moreover, you declare the combination of that primary key as well as this one, the partial key, as the primary key for this one, right? And moreover, by writing like this, even this identifying relationship has been taken care, which means you need not do anything for the identifying relationship also. It is also being taken care by this. How is it taken care? By including this foreign key, right? So foreign key is not just about the weak entity. Weak entity is already represented as a table, and this relationship itself is actually represented as the foreign key. Therefore, by including this foreign key, even this this identifying relationship is also represented. You need not worry about it later. Got it? In case if it is having any attributes, the identifying relationship, you generally will have it here. Got it? Okay. So one thing you should be careful here is, what about the integrity violations? Let us say, in case if you are deleting an employee element here, then what should be done? So in case of weak entities, right, since the dependence, there is existence dependence means there cannot be any dependent without any employee, right? So in case of such a dependency, especially in these cases, in case of this weak entities and identifying relationships, if you ever delete any entity from the owner entity side, you should delete all the entities which are depending on that. Therefore, on delete and on update, it is cascading, which means if you delete something here, you should even delete there. Got it? Where especially in the weak entities, right? So when there is a weak entity and when there is this reference, which means there is a foreign key which is referring to a owner entity, then whenever you are going to delete something here, you are supposed to delete all the entities from this side, right? And this rule is applicable especially for this weak entities, right? Not for other things. And in the other case, see, whenever there is this foreign key, it does not mean that the entity is weak. Here we are going to have the foreign key, it doesn't mean that the entity is weak, right? And whenever there is total participation, it doesn't mean that entity is weak. It here so happened that the entity is weak, but then even without this weak entity type, there will be total participation, and even without this weak entity type, there will be cross referencing, which means there will be a foreign key which will be referring to the primary key of the other table, right? Therefore, only in case of weak entities, whenever there is deletion here, we are going to delete all the tuples here, because without the owner, there will not be these dependents. Got it? So in case of other relations where we are going to have these cross references, cascading need not be applied, and cascading should not be applied according to the semantics. Okay, I'll show you there. Fine.